Hi, Prachi. Hi, Shruti.
Okay, we'll start in just a minute. I'm just pulling up the physics stuff. Okay, let's get started. Is there anything specific you guys want to go over? I think for this test, it's mostly going to be 1.2 graphing and uncertainties and stuff like that.
Yeah, if we could just, I was really just trying to just get a review on like the uncertainties and the slopes and that kind of thing, just to get some practice. That's all.
Let's just go through her PowerPoint. So for the test, she's gonna give us like a table or something of values, and we have to graph it, right?
Yeah, she said it's going to be like a lab report, so we might need to do some analysis as well. I was thinking, I don't know.
Okay, we haven't actually gone over lab reports in class though.
I think it's just like the general stuff, like just the graphing and then the basic interpretation, like she might have like questions, guided questions or something. I don't know. I don't think she expects us to do a full on like hypothesis and all that.
Yeah, because the ones we did for physics last year, that like he wanted some like pretty specific stuff.
Sure.
So
Okay.
hopefully it won't be that specific this time. Okay, so linearization is just the isolating variables like we did last time. You just need to have it into y equals mx plus b format. Anyone have any questions? We can maybe go over some practice problems after this. But I think they're the same ones that we already did, so I don't know how helpful it's going to be.
Are there any like problems in the Oxford or IB or the Cambridge ones that she has on her Schoology?
Oh, I don't know. I haven't checked those. Let's finish going through this, then I can check. Okay, so I guess these are just like some general rules for drawing a graph. Oops. Okay, obviously like the independent variables on the x-axis and the dependent variables on the y-axis. I think we have to mark the actual points that she gave us. Those we have to mark, and then the line we can just kind of approximate after we do the linearization. So the linearization tells you which variables should be on the x-axis and which one should be on the y-axis. And then the error bars depend on how much error was in the experiment. So maybe we can go over uncertainties as well. And then the outlier, I think you leave it on the graph, but you should be sure to like mention it if she asks you any question, like attempting to like summarize the data or something, maybe you should mention the outlier. And don't assume that the line should pass with the origin. It might start like earlier, or it might have like a y-intercept, like a positive y-intercept.
So when you're drawing your line of best fit, do you just stop at the first and last points, or do you still go through all the points? Like because like say you wanted to extrapolate data, then you would need for it to go through like past the
endpoints, I would say, I mean, I feel like if she's not asking to extrapolate data, I would just leave it, because we don't actually know what's like after the last point or before the first point. So I don't actually know. She hasn't said anything, but I feel like that would be the safe thing to do.
Okay.
Okay, what's next? Okay, so instead of finding the error bars for each point, just take the worst value, so like the biggest error bar, and she's using, and then use that same error bar for all of them. So whichever error bar is the biggest one, I think you just apply that for all of the points, just to keep it like uniform and not have different error bars for each value, because that would get confusing. Okay, at the end of the lab report, you should discuss the experiment results, what type of dependence, or like correlation, anything like that you discovered, maybe cause and effect. Although it's easier to prove correlation than cause and effect. So, and then any like random or systematic errors that you see. Okay, max and min lengths. I know this was like it was confusing for a lot of people when we learned it. We use okay, so if we look at this graph, you would use like the top left corner and then match it to the bottom right corner, I think, of the last one, to find the maximum slope, because that one is steeper. And then you would do the opposite. You would use the bottom right corner on the top point and then the top left corner on the bottom point to find the minimum slope, because you can see how like this one is obviously steeper than the other one.
So when you're doing it, so say you only took the worst uncertainty, then you wouldn't do the box anymore, right? Then would you just take the top and the bottom? Or would you do bottom, top, and then top, bottom?
No, you would still do the same thing, I think.
So even if you like just took the worst uncertainty, like rather than do the whole cross, if you just did the worst uncertainty for each, then you would still draw out the box?
Yeah, you would still have a cross, because you would have the worst uncertainty for both the x and the y. And then the reason we do the box, yeah, the reason we do the box is so you account for both the x and the y uncertainties. So this is like the lowest x and y uncertainties for the highest point, and then this is the greatest x and y uncertainties for the lowest point, and that gives you the minimum slope. And then it's just the opposite for the maximum slope. And then for uncertainty, you always just do max minus min over 2. Yeah, this is like a clearer picture of the box that we're supposed to draw. Okay, and then when we do the line of best fit, it's not, so when I did this question, I actually chose D, because that one seemed like more of like a straight line to me. But B is the correct answer, because this line goes through all of the error bars. So whenever you draw a line of best fit, it has to go through all of the error bars. So like we need to prioritize that over it actually being straight. Okay, and then in general, whenever you do an experiment, IB says you should have 5 variations of your independent variable and then 5 trials for each of those. So that's like a good number of values to have for an experiment. I think this was just an example table. Will we need to do tables, or is it only graphs on the test? Does anyone know?
I think she'll give us the data like it's presented right there. And then she might be like, add the column, fill in the column where it's like, find the average, and then find the uncertainties. You know how it was in the practice problems? Actually, can we try that? Like, can we practice with this data set?
With this data set, yeah.
Yeah.
I wish there was a clear version of it. Hang on.
I just downloaded it. Okay, yeah, it might be in the PDF version, yeah.
I'm just gonna download it. Can you guys see the PowerPoint?
No.
No? Okay. Okay, there we go. Okay. Okay, so this is I think this is like an exemplary table. Okay, it still has words here. That's so annoying.
I think it's because they're like animations, so if you like present it, probably, it might work.
Wow, what happened? Okay, wait, maybe I can.
Yeah, maybe you're just trying to get rid of it.
Yeah, I was trying to get rid of it.
Yeah.
Okay, it's fine. We can still mostly see them. Okay. So I think the first thing that we'd have to do is find the error bars for the X and the Y. I think, do we average them first? I think we need to average them, right?
Yeah, okay,
Yeah, so
okay.
Average, we need it, so for 0 seconds, we would need to average all of the trials for 0 seconds, and then you would average all the trials for 10 seconds. So for each X value, you would have one Y value instead of having 5.
Let me write down the steps, because I feel like if we have a step-by-step process, we can also share that with others later. That way.
Okay.
So the first thing you said was to take the average of each of them?
Yeah, take the average for each type of trial. So
okay.
for 0, for the X, you would take in the average of all 5 trials.
So each argument essentially, so for each argument, yeah. I guess you can call them argument in this case, take the average of each. Yeah.
Yeah, just to make sure we only have one Y per X, so we can linearize.
That's kind of like the best estimate, that thing that she says. Is that it? Like when she says, measurement, when you report your answer, it's best estimate plus or minus uncertainty. So this would be the best estimate partner. Okay.
Okay, and so for the uncertainty, I know here it says 0.05. Oh, okay. Here it says 0.05 centimeters, and earlier I know we were confused about whether or not to use this given uncertainty or the one that we calculate. I think we use the one that we calculate. I think that's the one, right? Okay.
Yeah.
So you would take the highest value, which is 14.9, minus the lowest value, which is 14.3, and then you would divide that by 2. So in this case, our uncertainty would be, that's not right. Our uncertainty would be plus or minus 0.3 centimeters for 0. And then I think you would just do the same thing for each of these times. I don't think we need to linearize this one because it's already pretty straightforward.
Yeah. Okay. So if it wasn't straightforward, then we would want to linearize it, right?
Yeah. Okay. But I don't think we're gonna have anything like that. She might give us a problem just for linearization, but I don't think she's gonna give us such a complex table that we'll have to linearize.
Okay.
That would be a lot of variables. Okay, and then the uncertainty for the X is already given. It says 0.2. Right, and then here it says for example, for a stopwatch, you also, this doesn't include human error. You would also have to factor in human error. I'm not sure if she wants us to include that on the test though, because it would be different for each person.
I feel like you would say that, and then under, you know how she wants us to specify that? I feel like that's where you would say it,
yeah, that's the same thing it did here.
Okay, kind of like exactly what they did there, probably.
Yeah, there's just an asterisk, and then it says underneath that they would probably be more due to human error.
Okay.
Okay. Okay, and then I think this would be your outcome. Okay, yeah, so we were right. It would be 0.3 for the uncertainty. And then you also calculate percentage error, which is pretty easy.
Okay, so percentage error, are we just doing that just because, or like, is there a purpose for that in the graph?
I think it's just part of the table. I think all of the example tables that she has of like process data, like first she has an example table of like just raw data, which is the one with all these trials. And then whenever she has one of process data, it has the average distance, and then it has the actual distance, which would be like the one that you'll state, and that includes the uncertainty, and then she has percentage error. So I think these three things are like pretty staple things to include in a process data table.
Okay.
Yeah, and then down here it says measurement uncertainty was distance was calculated by range over 2. So you would do that instead of
So you would specify that as well?
Yeah.
Okay.
It's probably best to specify. If you're not sure about something, just write a little note next to it or underneath it.
And then percentage error is the uncertainty divided by the best measurement, right?
Yeah.
Or,
uncertainty divided by best measurement times 100.
So how come there's average distance and then also distance? Is that just like the rounded version for that one on the right?
Average distance is just taking the averages of like these trials, right? And then the distance is like what you would state if you had to say like how much was the distance for 0 seconds. This is what you would state, because you need to include 0.3, like the uncertainty, in your stated measurement.
Oh, okay. Thank you.
Okay, and then next we move on to graphing, and then graphing is pretty straightforward. If you don't have to linearize, you just plot the points. So make sure the points are clearly marked, and then draw in the error bars. And then after you're done doing that, then you can draw a line. It should stay as close to the points as possible, and it should be a straight line. And if you can't have it like on the point, it needs to be at least within the error bars. So within the error bars, as close to the points as you can get it while still being a straight line.
So it looks like like for the horizontal one, it's the same, right? Because the uncertainty for the horizontal was the same each time, since that had to do with the time.
And then I think for the vertical one, I'm not sure if it's.
I think she took the worst, because that's what it says, right? Maximum measurement uncertainty. Okay.
Yeah, I think she took the worst. I was just trying to tell if it's that way on this. I think it is. Yeah, she just took the worst one. So I think in this case, the worst one would be 0.3. Actually, a lot of them are 0.3, so it's not that bad.
Got it.
So you would just take the worst uncertainty and do it for all of the y uncertainty.
And then we need to specify that underneath, right?
Yeah. The worst uncertainty was taken for all of the y uncertainties. Or the uncertainty in distance, I think that would probably be a better way to put it. Yeah, it actually says it right here. The size of the vertical error bars in the graph is 0.3, which was the maximum measurement uncertainty. Okay, and the next step would be to find the uncertainty in the slope. So you would find the maximum slope and then the minimum slope, which is the boxing that we talked about earlier. And then to find the uncertainty, you would take the max slope minus the min slope and then divide it by 2. So it's the same thing as range over 2, but just in slope.
Sorry, say that one more time. So you do max minus min over 2, right?
Yeah.
Okay.
It's the same thing. It's the same thing as like, you know how you take like the range of values divided by 2. It's the same thing, but just with slope, because it's the max minus the min. Okay, that's pretty much the end, actually. Yeah, so you might also ask you to find the uncertainty in the y-intercept. It's the same thing. You just find the error. You just look at the error bar for the y-intercept, and then you would do the max minus min over 2. So it's the same. It's range over 2. Uncertainty is usually calculated that way.
Okay.
Some graphs, I don't know. Some graphs might not have a y-intercept, because I know she said like, don't assume it goes to the origin, so I don't know. They might not all have y-intercepts either.
Okay, so don't assume it goes through the origin, but it can go through it can have a y-intercept. It just, that doesn't, okay, so, well, I think, well, is she trying to say that basically don't force it to go through the origin, but it can still have a y-intercept, or is she just saying don't assume past the data?
I think she's just saying don't assume anything. You just kind of have to look at the graph and see what it looks like. Like for this, obviously, you can't make this go through the origin. It wouldn't make any sense, right? But for another graph, if the line maybe looked like starting from like here and then going up till here, then it would have an x-intercept instead of a y-intercept. So I don't think you can't really assume anything with an intercept. You just have to look at the graph and see how it goes. Okay. You guys have any like specific questions? I think we have about 9 minutes left.
Okay. All right, I've basically made a summary. Okay, so for the maximum slope line, it's top left and then bottom right, right?
Yeah. Okay. I don't really remember the corners that way. I just kind of look at it and see how you can find like the steepest possible slope. So you would want like the lowest values for the bottom one and then the highest ones for the top point. Okay, if you guys don't have any other questions, I think that's...
Can I just go through the steps? Okay, so basically first thing you do is take the average of the trials for each independent variable. Then you calculate the uncertainties for each independent variable by doing max minus min over 2. Then the third step is you report the measurements as average plus minus uncertainty and then the unit. And then that's when you use the proper sig figs and you round with the precision and all that. And then you calculate the percentage error and you put that in an additional column.
Yeah, so those three things, I guess those two things, the measurement with the uncertainty and the percentage error, that counts as like the process data table. I don't know if she's gonna use those words on the test, but she did mention that in class several times.
Okay, all right. So basically this stuff right. So the average plus minus and then the percentage error and then the okay. So everything that we just talked about, this is the process part, right? Mm-hmm. Okay. And I'll share this on the Slack as well. That way you'll have this. Okay. And then the next part is you graph the points with the error bars, and the horizontal error bar uncertainty is going to generally be the same. But then for the vertical uncertainty, you take the worst or the maximum uncertainty. And then once you do that, you need to specify that you took the worst uncertainty. And then you draw your line of best fit, but don't assume it goes past the data points. And then the last step is to do the max and then the min slopes and then the y-intercepts. Right?
Yeah.
Okay.
Pretty much anything, if you're doing something that you're not sure if it's like standardized or not, or like something that it says in the rules that you always do this, I think you have to specify, like what we said for the uncertainty and stuff like that.
Okay. Okay. All right.
Do you think she's going to make us do like vectors with uncertainties? Like if we have like Newtons or something, that she'd make us like, you know, do uncertainty with that?
I don't know how uncertainties would work with both magnitude and direction, but I don't think
because a lot of time you take like the square root. I don't know how uncertainty would work with square root because it's not multiplication or division. It's just, I don't know. It's just a different function.
Okay.
I don't think she'd make us do that. She hasn't mentioned that in the class. I think that's...
Yeah, I don't think that she'll go that far.
Yeah. So I think all you need to know for this test is probably just the graphing and the uncertainty. Maybe go over like sig fig rules and stuff like that. It's most of 1.2.
Cool.
Okay, is there anything else you guys wanted to go over specifically?
That's pretty much it for me. I don't know about anyone else. I'm just trying to get a summary down, and then just for my sake at least, 'cause I know I have to think in that step-by-step manner. Otherwise, I lose track of it.
Okay, I think we're pretty much done here. MG, can you send the step-by-step thing on the Slack?
Sure. Yeah, definitely.
Okay.
All right.
Great. Thanks for coming, guys.
Bye. Thank you.
Thank you.